Now we will define exponential relationship. Two quantities have exponential relationship if one can be represented by raising the other as exponent or power to some constant values. So we will illustrate or explain this definition of exponential relationship using two examples. So let us first consider this first case. A bacteria cell divides into two in every 1 hour. So we will find the number of bacteria cell after a certain number of hours. So let us first start with the initial number, that is the number of cells at the beginning. Number of cell at the beginning is K. Then the number of cell after 1 hour will be, because the cell divides into two in every 1 hour, that means every cell will produce 2 cells after 1 hour. So for initial K number of cell, after 1 hour the total number of cell will be K times 2. Then, so that is after 1 hour there are 2K number of cell. Then number of cells after 2 hours. So after 1 hour there are K times 2 number of cell. Each of this cell will divide into 2 after 1 hour. So there will be K times 2 times 2, which is K times 2 square. Then the number of cells after 3 hours will be, after 2 hours the number of cell is this. Each of this cell will divide into 2. So the number of cell will be, this is after 2 hours, then every cell will be doubled, so 2. So we will be getting K times 2 to the power 3. So in this way, after 1 hour it is K times 2 to the power 1. After 2 hours K times 2 to the power 2. After 3 hours it is K times 2 to the power 3. So in this way if we go, then number of cell after X hours will be K times 2 to the power X. And if we represent this number of cell after X hours is Y, then this Y will be K times 2 to the power X. So here the relation X and Y, the relation between X and Y, the Y is equal to 2 to the power X, that is one quantity is X, one quantity is Y. Y is the number of cell after X hours. So X is the number of hours. So one quantity equals the other quantity is raised as the power. That is why it was stated the two quantities have exponential relationship if one can be represented. Here Y is represented by raising the other as exponent or power, by raising X as the power. So this relation is an exponential relation. Let us consider the second case. In every century, 1/3 of all species are going extinct. So we need to find the number of species after certain centuries. So let us first consider, let the number of species at the beginning of observation is K. Then 1/3 of all species is going extinct in every century. So that means after 1 century the number of species after 1 century will be 1/3 is going extinct. So that means rest, that is the 2/3, will still be there. So it will be K times, initially it was K, so now the number of species remaining will be 2/3 of k. One third is extinct, so the remaining number of species will be 2/3 of the initial number of species. Similar way, number of species after 2 centuries will be, after 1 century the number of species is this, and among them 1/3 is extinct, so another 2/3 is still there. So k times 2/3 times 2/3, which we can write as k times 2/3 whole square. So after 2 centuries the number of species remaining is this. Then, so after 2 centuries this is the number of species remaining, and in another century 1/3 will be going extinct and another 2/3 of this will remaining. So number of species after 3 centuries will be this much, k times 2 division 3 whole square, its 2/3. So this can be written as k times 2 division 3 to the power 3. So after 1 century it is k times 2 to the power 2 division 3 to the power 1. After 2 century it is k times 2 division 3 to the power 2. After 3 century it is k times 2 division 3 to the power 3. So in generally after x century the number of species, if we represent by y, then this y will be k times 2 division 3 to the power x. So here y is the number of species after x century. X is the number of centuries. So y is represented here by raising x as the power. So this relation, this x and y relation, that is number of species remaining after x centuries, this relationship is an exponential relationship. Now these two, both these relations are exponential relation, but as the hours are going, that is as x is increasing here, the number of cells is increasing because it is 2 to the power x. As the value of x will increase, the number of cells will increase. So in this relationship, y will be increasing with the increase of x. That means y is growing with the growth of x. So these kinds of exponential relationship is called exponential growth. But in the second case, as the x, since 2/3 is less than 1, as this x value is increasing, the y will be decreasing. That is, as the century will go by, the number of species will reduce. So with the increase of x, the y, that is number of species, is decreasing. So these kinds of exponential relation is called exponential decay. That means in summary, exponential relation, two quantity got exponential relation if one can be represented by raising the other as the power on some constant value. In general we can write y equals k a to the power x. So this x and y are exponential related, where y is represented by raising x as the power of a constant a, and if x increases, if y increases as the x increases, then the relation is exponential growth, and if x increases, if y decreases with x increasing x, then the relation is exponential decay. During an experiment, Alex observes that a bacteria cell multiplied into 4 cells after first day, 16 cells after second day, and 64 cells after the third day, and so on. How many cells there will be on the 4th day? Okay, so at the beginning a bacteria cell, so at the beginning the number of cells at the beginning is 1. So the number of cells after 1 day is cell multiplied into 4 cells after, so there are 1 times 4 multiplied into 4 cells after 1 day. Then number of cells after 2 days, 16 sales. So it will be 1 times 16, which is 1 times 4 square. Then number of sales after 3 days is 64. 64 we can write as 1 times 64. That means 1 times 4 to the power 3. 4 times 4 is 16. 16 times 4 is 64. So we can see a pattern that after day 1, the number of sale is 4 to the power 1. After day 2, the number of sale is 1. We don't need to multiply. 4 to the power 2. After 3 days, it is 4 to the power 3. So question A is, how many sales there will be after 4th day? So the number of sales after 4 days will be 4 to the power 4. If we calculate it, we will get 256. 4 times 4 times 4 times 4 is 256. Question B is, how many sales there will be in 5th day? So number of sale in 5th day will be 4 to the power 5. If we calculate it, we will get 1024. Question C is, express this relationship between the number of sales with the number of days by an equation. So the number of sales after T days. So if we define it by NT, then it will be 4 to the power T. 4 to the power 1, 4 to the power 2, 4, 3, 4 to the power 4, 4 to the power 5. So after T days, the number of sales, if we define by NT, it will be 4 to the power T. So this is the exponential relation for the number of sales after T days. Is this relation is exponential? Yes, because here the number of days, this variable is raised as the power on a constant 4 to get the number of sales. So this is an exponential relation. Use this equation to determine how many sales there will be in the 10th days. So on the 10th days, T will be 10. So the number of sales on 10th day will be 4 to the power T is 10, so 4 to the power 10.